I gotta say, this is just fascinating. I understand you met with the researchers, but I want to start off with a question. Why launch those cells into space? How does that help?
So the microgravity in space acts as an accelerator. Scientists can learn how diseases like osteoporosis or kidney stones develop in weeks instead of months or years that it takes here on Earth. They're hoping launching their experiment into space will lead to breakthroughs in treatments and prevention.
We don't really understand kidney disease as well as we should. We lump it all in as one big disease, and it's not. Kidneys do a lot in the body, more than just making urine. They control the acid-base balance in the body, they control water levels in the body, they control drugs and toxin levels. They can control the vitamin D regulation in the body, and they can help to build strong bones. So when the kidneys start to fail, all of these processes can go bad. We test drugs for kidney patients in a very small number of patients. It's very difficult to find patients for these drug studies. When we test medications before they get into patients, we're using animal models. And animal models will often give us results that are incorrect. What we need to do is make sure the drug works and is safe in people. And I think using something like a kidney on a chip will give us information that we can directly relate to people.
The kidney chip system represents a revolution in drug safety testing, and this is a technology which allows us to really jump over the use of animals because it's actually modeling what happens in human cells. We take human kidney cells and put them into this platform. Media flows through here and then passes through our chip, and then what comes out is the functional equivalent of urine. And so we can actually put in various drugs and toxins to see how it affects the kidney chip, then monitor what comes out in the effluent, which then actually is akin to looking at urinary biomarkers.
We can do a lot of things with the kidney on a chip. We can look at what happens in kidney cells when the cells are exposed to low levels of drugs for a longer period of time. We can also use the kidney on a chip to test whether or not medications would be effective for certain patients with certain diseases. The goal is for us to understand how kidneys work.
We get to do science in a unique environment, the International Space Station. We're going to use that very unique environment to model various disease conditions and scenarios in the kidney chip that we know are accelerated in microgravity.
Historically, astronauts were pilots that they trained to be scientists. And now the new group of astronauts seem to be scientists that they're training to become astronauts.
So what we'll be doing is creating our chips on the ground. They'll then go up into the International Space Station.
We'll have a system with interchangeable syringes. And as the experiments progress, the crew members will swap out the syringes at designated time points, change out the collection vessels, collect the samples. When the experiment is done, they'll freeze everything and they'll ship it back to us. You know, if we can initiate the very early stages of kidney disease in these chips based on microgravity or exposure to radiation, maybe we can see the very earliest signs of kidney cells beginning to fail. Maybe we can detect in patients the very earliest signs of kidney disease. Maybe we can learn something that we've never been able to learn before. We've got a good team, and it's going to take all of us working really hard for the next year and a half to get this thing together. But we're very excited. Super excited.
Dialysis was invented here in the Northwest. This is the heart of innovation in kidney research. And so I think having the support of Northwest Kidney Centers is something I can't overemphasize their value.
Funding agencies are very risk averse. They want their money to go to projects and experiments that they're sure will work. The problem with doing very innovative experiments is that you don't know if they're going to work. So the funding from the Northwest Kidney Centers allows us to explore those very creative but very risky projects. Sometimes they don't work, but sometimes they do.